this car every day, or?
I would like to, but it's not finished, and to get it certified costs about $500.
Right.
So I can certify it now, but then I have to certify it again when I add 100 kilos of batteries.
Okay.
And add 100 kilos of batteries and triple the power. So it really does have to be certified again.
Right, so it's really just sort of like a project that you've got at home.
Yeah, I did commute for 3 weeks in it when my other car blew up.
Oh, yeah.
Didn't get forced in the project.
What's the cost of pulling it up compared to gas?
Everyone asks me this, and then I have to do calculations in my head. It's cheap.
So if you include the solar panels, it's still free. I've still got 27,000 Ks for free every year, and everybody else is paying $4 a litre.
And that's because you've got solar panels on your
I've got solar panels on my roof, yeah.
But
Well, I don't need to roll the car over because I just have a good car, so I don't see the need to roll the car over. Like, if I've got a car that costs me nothing to run and it's really, really nice to drive, why do I need to go and get a new car? And I don't have a big ego to think, oh, I need a new car.
That's what
I've got a better car than everybody else anyway.
The electric car, it basically, it still isn't as good as something like a train in terms of efficiency. They're very hard to beat, but they're a bit more flexible in order to be able to get people around. And the technologies are improving every day, so I think we should see them on New Zealand roads, I think, in the not too distant future. Public transport is only a pretty small section of the energy requirements. People think of, well, the oil prices are going up, that means my gas price goes up. But really speaking, there's a whole lot of other issues. One is getting to market. I'm talking about, overseas, US, obviously trying to get large cargo ships over the sea. So one of the things I've been thinking about is how to do that at relatively low cost. And obviously one of the previous technologies that we've seen in days gone by is the sailing ship. And obviously it's gone out of fashion. I'm not talking about building a whole lot of wooden sailing ships here. Obviously modern sailing ships, cargo sailing ships, obviously, you'd make them out of relatively modern building techniques like carbon fibre, fiberglass technologies that are light and possibly also quite small. In other words, compared to today's modern cargo ships, for sailing to really work, you can't have enormous, huge, great ships. But what you could do is have a reasonably large number of them, and rather than having people on board these ships, you could have them drive themselves around autonomously. And that's why I've got this picture. It's not a cargo ship, but it is a autonomous boat. Has basically a wing on the top instead of a sail, and you just tell it where to go, and it's able to sail wherever it needs to go. So this kind of approach could be used for cargo. Now, I'm only using it as an example. I'm not necessarily saying the world should immediately be ready to sail powered ships, but I think we need to start thinking laterally in terms of how we solve our today's problems, rather than just basically coming to the conclusion that we need to be doing things always the same old way that we've been doing it. If you're going to have autonomous boats, you need some kind of advanced technology to be able to drive them around. And I saw this open source project a few weeks ago, and I thought this really quite special.
My name is Zdeněk Kálal, and I'm a researcher focusing on visual object tracking. This red dot is the result of my PhD thesis, where I investigated how to track an unknown object in a video sequence and how to improve the tracking performance during tracking.
I brought that up video basically because I wanted to show how software technology can be used to enable technologies that help us achieve objectives such as being able to have autonomous sailing ships get our goods from place to place. So that's only an example. I'm not suggesting, as I was saying, I'm not suggesting we necessarily use that specific technology, but maybe we can use those kinds of technologies to do other wonderful things in terms of automating vehicles, possibly to make them safer. For example, on the roads you might make things safer, and be able to, I mean the example I had was sailing ships, because that's a clear reason we would want something. The other thing is the piracy problem. I wondered what would happen if you had ships with this kind of technology on it, able to guide themselves through through dangerous waters. And if all of the electronics and control systems are deep in the bowels of the ship, obviously trying to get on one of those ships becomes pointless, because you have to be able to somehow remove the cargo while you're on the water. It becomes a much more dangerous, difficult proposition to try and capture a ship if all of its control mechanisms are deep below the waterline. So it was an interesting idea. Well, not all ideas are that way up. There's been a lot of work done in the area of home power. The one we're probably most familiar with is hot water, just having a solar array on the roof and having your water hot heated up by your solar panels. But if you think about it, most of the energy applications in your home are heat applications. And going back to the engineering problem of do you really want to take that heat and turn it into electricity only to turn it back into heat again? The answer is probably no. That doesn't mean you necessarily want to eliminate electronics and control technologies from the picture. In fact, quite the reverse. You want to be able to try and leverage control technologies to be able to capture heat more efficiently. So we have cooking, hot water and home heating are the primary uses of electricity in the home, because they're what take most of the energy. Imagine if you could have a collector on your roof which collected all of the heat and then put it into some kind of so we say high temperature storage system. So we're not talking about water anymore, which basically turns to steam at 100 degrees, so that's not really very useful. Imagine if you could have some kind of collection system which could store heat, perhaps at 300 or 400 degrees Celsius, and rather than water you might use, say, salt or something like that. So what happens then is that if you want to cook your food, you just run some water through it, it turns to steam, you pipe the steam to where it needs to go. Let's say we're using steam, you could also use oil or some other kind of medium, and then voila, you've got a stove. If you want hot water, cool. All you do is you have a short path through the salt. It heats it up, heats the water up, but doesn't quite. Basically, it's a heat transfer system. Heats the water up, but doesn't quite boil it. You make sure that you've got the electronic controls to push the water through at just the right rate, and suddenly you've got, well, not quite limitless, but a hot water system without having to have the big hot water cylinder. So let's say you want to heat your home. Well, you can do the same thing. You just run the water through, it turns to steam, you run it through a radiator. Wonderful, you've got a home heating system. And finally, if you want electricity, you run it through a steam generator or possibly a Stirling engine. Suddenly you've got electricity for the home as well. The real problem I saw with solar was that in order to turn it to electricity, the efficiency at the moment is really quite pathetic. Okay, so I mean, if you have a solar array which captures heat, it's not quite, but pretty close to 100% efficient, so long as you have the right barriers in place. If you've got vacuums, if you're using vacuum collectors, for example, then it can work quite well. If you haven't got that, if you're using some of the modern day, some of the mass-produced ones, solar collectors today, they tend to be inefficient because they allow heat to escape from the solar panels. But if you have properly vacuum-sealed tubes, then these can get to quite extreme temperatures. And the problem with those sometimes is you hear the solar people saying they get too hot, and I think that's a pretty good problem for a solar installation. So I think the real problem is the medium. And most people are using hot water, using water as the medium. That has a very limited range, temperature range before it tends to steam. After that, you have obviously enormous pressure problems. So it's better to use something that's not going to give you those pressure problems and can be used effectively.
Well, the water has got a very, very high heat capacity, so you can actually carry with rather little amount of water a rather high amount of energy, which if you use certain oils that you might be able, let's say, to heat to 300 degrees or something, they might still carry less energy than water at 100 degrees. So.
That's true. So I mean, oil is, well, you could still use oil as the heat transfer mechanism, but not necessarily the storage.
Yes.
So that's why I've been looking at other materials for the heat storage. So it depends on what
water
role.
under high pressure is also a way potentially.
Well, yeah, that's true. But the problem is high pressure. If you've seen Mythbusters, what happens to high pressure when it fails? Yeah, that's not good. Well, either is escaping salt for that matter, but part of the problem is trying to solve some of these issues. Come up with a system that's safe, yet has a has a very high energy capacity in it. It doesn't matter whether we're talking about batteries or heat storage, like I'm talking about. The primary problem we have at the moment isn't collecting solar energy, although obviously some systems like PV are very expensive and hardly economic. But even the problem is, even if we can collect the energy, where do we put it?
Storing and transferring.
Yeah, well, I mean, so just about to get to one answer, and that's, sorry.
I think in some, like nuclear power plants, they're using lithium for that purpose, but that might be a wee bit too high in temperature.
Well, one approach is to use it. In other words, there's some people generating it at some time, other people generating it at others, and the usage doesn't coincide with generating it. So one concept is there's this concept called SolarNet, and so what SolarNet does is it's like a network. It uses the internet to be able to coordinate a whole lot of people with the grid tie systems. So it basically means that they coordinate the best time to provide their energy and use their energy. So it's actually, I mean, you can't do much about generation actually. The sun's shining, you're generating it. However, you can do something about when you're using electricity. So, I mean, for example, if you've got your electric car, you might want to charge your car at the time which is the lowest cost for your electricity. So now there's these really smart meters coming into play, where the electricity company can tell you basically when the low peak or the low cost periods are and where the high cost periods are, and then the user can manage their electricity usage. So this applies not just to solar installations. I mean, the average Joe Blow might want one of these in order to be able to save money on their electricity bill. So yeah, one of the keys is, if you want to, what's the word? There's a dollar saved is a dollar earned, right? Well, it's the same for electricity. If you want to save electricity, don't spend it, or at least spend it when it's a lower cost. So this is an open source solution on SolarNet. Basically, there's a group of solar aficionados who have got together, and they've got together with the electric companies in the States, unfortunately not New Zealand at this point, I believe. But they've got a standard in terms of how the energy companies talk to the consumers over the internet in order to be able to arrange and organise the entire network.